manage nutrients in agricultural watersheds. And so you can see here, for example, that a great part of our state is cultivated, right? So the southern part and then the western part of the state, mostly. And so in these agricultural watersheds, the main nutrients of concern for water quality are going to be nitrogen and phosphorus, but then as you will see later on, suspended solids as well. And so once again, the main concern here with phosphorus, for example, or nitrogen is going to be eutrophication. And so as you saw earlier, that concern is different depending on where we are in Minnesota. And so in northern Minnesota versus southern Minnesota, for example. But then overall throughout the state, per the Minnesota Pollution Control Agency, about 50% of our lakes are considered to be swimmable. And that is mainly because of pollution from phosphorus. And so regarding the organic matter that ends up in lakes, so terrestrial carbon is also called allochthonous carbon. And so, for example, let's just imagine that we have a clear lake, a lake that doesn't have any contamination from runoff or terrestrial carbon. And so then we add that terrestrial carbon. In this case, let's say that is dissolved organic carbon. And so what is going to happen is that this carbon is going to block the sunlight. We're going to have lake browning. We're also going to change the color of the lake. And then this in turn is going to affect the biological or the ecology of the lake. And so will affect primary production. We won't have as much photosynthesis as we did before. Will affect secondary production as well because of that in the whole trophic level. And then we are also going to affect the, in this case, the metal expression or the toxicity of metals will increase because of this organic carbon. And then finally, the cycling of inorganic nutrients will also be changing because of the addition of carbon into a lake. And so again, we're disturbing different parts of the biogeochemistry and the biology of a lake. And so this, again, this carbon is detrimental to lake water quality. And so when I was looking at the literature for my thesis writing, I noticed right away that, when you go to an ecosystem, it's kind of hard to find literature that talks about carbon in an agricultural setting that is more talked about in the limnology setting. So I wanted to put that on the record for my research. And so we did actually investigate the loads of carbon in our samples. And so another motivation for this research was due to the changing winter conditions with climate change. So in the state of Minnesota, for example, in the past 100 years, we've had an increase of about 4 degrees Fahrenheit for the month of January. And then also for the month of January, we have had a 5-time increase in the frequency of freeze-thaw cycles in the month of January since 1950. And the reason why I mentioned freeze-thaw cycles is because of how cryoturbation can affect organic matter. So whether it's in the soil or in this case in manure that we're talking about. So the increase in freeze-thaw cycles can help break up that organic matter, and we are going to lose that physical protection for some of the labile compounds and create more dissolved nutrients in the runoff. But there are also a lot of benefits to manure. So manure is an important source of nutrients for crop production, and it has some advantages over synthetic fertilizers as well. So manure has a high content of soil organic matter, and that is going to help us spur the microbial activity in the soil. It's going to help with soil aggregation, and then these aggregates are going to contribute to better soil structure, better infiltration, and then we're going to increase the water holding capacity of that soil as well over the long term, usually. And then, these are components that, of course, can potentially help with water quality as well. In the state of Minnesota, the USDA takes account of all heads of cattle that we have in the state. And so that can vary year to year. However, yeah, you can see here in this graph that usually it is over 2 million heads of cattle in the state. And so we have a lot of manure. And so that manure has to go somewhere. And unfortunately, manure it can be really expensive to transport. And so it's also very difficult to transport. And so it is going to be applied with, very close to the source. And so in this case, on average, in Minnesota, we have about a transportation of about 1.36 miles from the source. And of course, as you know, manure is produced year round. And so it has to go somewhere even during the winter. In this case, small farmers or small producers sometimes just don't have adequate storage, or they don't have enough storage. And so they have to apply manure during the winter time. And this is applied under, not very ideal hydrological conditions. We have frozen soils, we have snow accumulation that can make it easier for nutrient losses during snowmelt runoff. And so again, that it's just not very ideal hydrological conditions. And so that is something that we were interested in our field study. This is our field study here. We did this during the winter of 2019-2020, and then again during the winter of 2020-21. And we did this on a plot right on the St. Paul campus. The research questions that we had, or our hypothesis that we had, were the optimal timing of application. So the timing of manure application could affect the nutrient loading to winter runoff. And then these nutrients were going to interact differently depending on when the manure was applied, or the timing of application. And we had 3 treatments. So we had a non-manure control. We had manure under snow, or also called the early manure, and then the manure over snow, or late manure. The manure that was the early manure application, it was applied over frozen soils both years, and there was no presence of snow at that time. We removed that snow that was present there. And then the manure over snow was applied actually both years. During the late manure application was applied over approximately 20 centimeters of snow. And so this is how we grouped the treatments the first year. So you can see how we did this randomization here. We had, the 3 treatments over 3 blocks. And so the early manure was applied on December 13 and on January 20th, the first and second years. And then the late manure was applied on February 6th, the first year, and then March 1st, the second year. And you can see here the rate of application for total nitrogen varied between 125 and 153 kilograms per hectare. And then the total phosphorus application varied between about 18 and 35 kilograms per hectare. So this is the timeline for manure application and sampling of the runoff during the first year. So during the first year, we did actually have snowmelt that occurred on December 30th. And actually that same day we had snowmelt, and then that night we had snowfall. So that was really interesting to see. And then we did have 2 samplings again in March after the second manure application. And then during the year 2, we didn't have any sampling between applications, but we did have 3 samplings as well during the month of March. And so this is what the treatments look like after the snowmelt was all gone. So you can see on the left side, that is the late manure. And so you can see that it's not incorporated into the soil like the right side is, the under snow manure. That is more incorporated into the soil, as you can see. The statistical analyses were a randomized complete block design, is our experiment. We did that with the Glimix procedure of SAS, which allows for mixed models, as you know. And then the year and treatment were treated as fixed effects, and the replicates were treated as, or the blocks were treated as random effects. The main effects were evaluated with the Tukey-Kramer adjustment. And then we had a p-value of 0.05 for significance. So we analyzed for nitrate N, ammonium N, total bound nitrogen, dissolved reactive phosphorus, total phosphorus, and then 3 types of carbon. So we have dissolved carbon, dissolved organic carbon, and dissolved inorganic carbon. And so typically what you see is you see the Kendall method for total nitrogen analyses. We had something else called the total bound nitrogen method, which is the combustion of, basically what happens here is there's a combustion of your sample where you're going to determine the total carbon content of your sample simultaneously with your total nitrogen, and in this case, being the total bound nitrogen method. And so this combustion happens between 700 and 1200 degrees Celsius. And the total nitrogen is then mixed with oxygen, so diatomic oxygen, and then that is converted to nitrogen monoxide, basically. And then that is then mixed with ozone, so O3. And then you create this kind of like artificially or like very unstably charged NO2, where you don't really know that the charge value, but it is in an excited state. And so then that will in turn release a photon that will get us to a neutral charge. And so that photon is then analyzed with a detector that detects light between 600 and 1200 nanometers. So like you are like near infrared to infrared light. And that is how this is detected, basically. So the statistical analysis came back with a significant effect for treatment for the nutrients in this case that we analyzed, as well as carbon. And so here, before I go into the details of the nutrients, I'm just going to explain what is in the graph here. So at the top, we have the name of the nutrient of concern. And then on the y-axis, we have kilograms per hectare. However, we have 3 different scales. You can see that this is 0.9, this is about 10, and then this is about 25 kilograms per hectare. And on the bottom, on the columns, the left side column will always be your early manure, the middle column will always be your late manure, and the right side column will always be your control. So in the case of nitrate, we were actually surprised because we saw more nitrate with the control than we did with the early or late manure applications. And so that was really surprising. And it was really interesting because we don't know why this happened. My guess is that there was microbial activity that happened where you have this microbial uptake or microbial immobilization of nitrate, or maybe you have denitrification happening that is consuming that available nitrate. And so that is really interesting to see. And so then, we can see that the nitrate in the control may have come either from the soil pool or from atmospheric nitrate deposition. In the case of ammonium, we saw a higher nutrient loads in the runoff from the late manure versus the early manure application. And that was also a bit surprising just because, you would typically see volatilization of something that is exposed to the air. And so then you would have, hopefully less losses to runoff in that case. But what happened here is that when we applied the manure on December 13th of 2019, the first year, it was left just exposed to the air during the month of December. And so we probably had a lot of volatilization that occurred the first year on the early manure application. And then during the second year of the late manure application, we sampled right away after application because we had snowmelt. And then also the manure experienced this like sinking effect the second year that didn't happen the first year. So like, I wonder if the snowpack was less dense maybe. And so again, you do see that significant difference there between late and early manure application. The total nitrogen, most of that came from ammonium, and as you can see here with these scales, and that was also again just greater with the late manure application as well. In the case of dissolved reacted phosphorus and total phosphorus, we didn't see a significant difference between the early and late manure treatments. We only observed a significant difference between the control and the two treatments. And so that is, I would say this is kind of difficult because when you're trying to improve best management practices, but you don't have this difference, it could be more difficult to assess those best management practices for agricultural, for water quality. So yeah. And then in the case of dissolved carbon, most of the dissolved carbon came from dissolved organic carbon. And we did see a difference in treatments as well here. So the late manure application had a greater load to runoff than the early manure application. And so when I was doing my literature review about carbon, there were a couple of journal articles that talked about the possibility that organic matter, when it's on top of a snowpack, it doesn't have that contact with the soil. It doesn't have that soil roughness that can prevent it from moving. And so that's why you end up having more carbon with the late manure application in this case. Also, the manure on top, there's another article that I read where it talks about how like dissolved organic carbon will leave the snowpack first with the first flash of snowmelt, and then the bigger particles will leave later on. And then dissolving organic carbon did experience a different effect. Like we had this like treatment by year effect on dissolving organic carbon. And so this is a little bit of a different graph. So you can see here we have year 1 early, late in control, and then year 2 early, late in control. And so the year 1 late manure application did experience a significantly higher nutrient load to runoff. This may have been because, so what happened in our study the first year versus the second year is that we had double the amounts of runoff the first year than we did the second year. We had double the amount of precipitation, and also the snowpacks were much higher the first year than the second year. And so this could be why we see this big difference here. So what does the literature say? So in reading articles that were similar to our research, I did learn that the early manure may inhibit erosion through mulching effect or this incorporation effect that you could see, for example, in one of the pictures that I showed you earlier. And so that could, prevent some of the nutrients from leaving the soil. And then the snowpack can have an insulation effect on the early manure that could aid in filtration. So how this happens is that when you have a high snowpack, that could protect the soil from the temperature shifts that occur in the air or in the atmosphere. And so then you have, lower temperatures near the top of the snowpack and then higher temperatures, but still freezing temperatures at the bottom of the snowpack. And then the late manure is more vulnerable to transport because there is no soil contact with that. And so again, organic matter can just move with runoff events. And then the late manure temperature shifts can be greater. So as I said before, with the freeze-thaw cycles, cryoturbation can occur that can create more dissolved nutrients and load those to the runoff. And then we also did a second experiment. This was a laboratory experiment. And so the questions there were whether the placement of manure within the snowpack can affect nutrient loading to runoff. And then the nutrients from manure will interact differently with snowmelt as well. So we had 4 treatments here. So we had a non-manure control. We had a manure under snow, and then manure between snow, and then manure over snow. So what happens here is we had these columns that were snow with the, it's a 30 centimeter column with a 15 centimeter diameter. And so the under snow manure is at the bottom of the 30 centimeter column. The manure in the middle is at 15 centimeters, and then the manure on top of snow is at the 30 centimeter height of that snow column. And then the leachate is collected at the bottom with a bucket, and the bottom of the snow column has these holes with a wire mesh that allow the water to go through, but then also that allows, that contact with the air as well, which is not something you would see in the field. And then the water equivalent of this snowmelt, the first year was about 1.5 liters, and then the second year was about 1.6 liters of snowmelt. The manure application, the first and second year for the total nitrogen was about 164 and 134 kilograms per hectare, and total phosphorus was about 33 and 23 kilograms per hectare. And so this is just showing you the year 2, but year 1 timeline was about the same as year 2 timeline because it's a control experiment. And so we did apply the manure and then froze the columns right away. And then we then started to thaw the columns 7 days later and started to sample the day after. So for over 48 hours, we were sampling. So we sampled twice and then refroze the columns. And then for 48 hours and then started to again thaw the columns. And so the reason why we did this freezing and thawing or refreezing and thawing is because we're interested to see if that has an effect on nutrient loading. And so then again, we had 2 samplings after the last of the snowmelt. The statistical analyses were again a randomized complete block design with the Glimix procedural SAS. The treatments were treated as fixed effects. And then here the year is a random effect. And then the replicates or the blocks are also a random effect. The main effects and interactions again were evaluated with the Tukey-Kramer adjustment. And our p-value is 0.05. And so again, we did analyze for the same loads as before, the same nutrients and loads of carbon as before. And so here we had a treatment effect for all the nutrients and for the carbon as well. And this was also very surprising to us because we had the same situation with the nitrate again. So here I will explain the graph again. So again, we have the nutrient of concern at the top. We have the kilograms per hectare on the y-axis, and we again have 3 different scales for the y-axis. And then at the bottom, we have on the left side, we have the blue bar manure under snow. The green bar in the middle left is the manure in between snow. The middle right column is the manure over snow. And then the right side column is the control. And so you will see that throughout. So again, the nitrate was higher with the control. And so again, this may be nitrate coming from atmospheric deposition into the snow. And so we may have had microbial activity again, as I said before, that is changing these conditions here. So where we have, as you can see, less nitrate with the manure treatments. Dr. Wilson, I think somebody is not muted. Then the ammonium N, again, most of that came, most of that ended up with the total nitrogen. So the the ammonium, the interesting part with the ammonium here is that you can observe there is a physical protection, right? So we understand that ammonium is going to leave the surface, or is going to leave the manure or the media via volatilization, right? And so you can see why we had less ammonium in the runoff or the leachate on the over snow manure, because that is exposed to the air. And so then we experience more volatilization. And you can see that effect of the physical protection that occurs with the manure in the middle, where it has 15 centimeters of snow at the bottom and on top. And the manure under snow has a little bit less of ammonium in the runoff, because that bottom part was exposed to the atmosphere as well. In the case of dissolved reactive phosphorus and total phosphorus, as you can see with the dissolved reactive phosphorus, we didn't see a significant difference between the manure under snow and the manure in the middle. But we did see a significant difference between those two in the over snow manure. And in the case of total phosphorus, we didn't see a significant difference at all between the 3 manure treatments. So again, that significant difference being just with the control here. And so here I was reading a couple of similar studies. Again, I think I mentioned this before, is where the phosphorus losses may be potentially dependent on the amount of water that is in contact with the source of phosphorus, right? So in this case, the manure over snow on the left side here, the left graph, the DRP graph. So the manure over snow didn't have the same contact with water as the other treatments. It had less contact with water because we have water coming out of the bottom. And so this manure over snow will not be in contact with that water from the bottom, where the manure under snow will be in contact with the entire 30 centimeter column of water. And so that may be a possibility as to why we see these. The dissolved organic carbon and dissolved organic carbon and dissolved carbon, again, you can see here that in the case of the dissolved carbon and dissolved organic carbon, we didn't see a significant difference between the treatments. And again, that could be because we don't have the presence of soil in these snow columns. And so, the presence of soil could potentially hold on to some of that carbon in a different experiment, right? And so here we're just looking at the effect of the snow in the snow hydrology on these rather than any influence from the soil. So the main findings for these two studies were that the field study, that the manure over snow showed higher total average of nutrient losses. So, and then in the lab study, we see that the effect of the placement within the snowpack can depend on the type of nutrient that we are referring about or that we're talking about. It can also be depending on the snowpack hydrology, that the insulation or the physical protection that can happen with a nutrient or the media that the nutrient is in can also be a factor for nutrient losses. And so, one of the limitations about the study could be that you don't have the presence of soil. However, without the presence of soil, we can also see the effects, that come from, not being influenced by the soil. So if a producer has to apply manure, based on our results, we would say that the early manure application may be best for water quality. Particularly if you're applying this treatment in the winter where the soil may still not be entirely frozen, that could be potentially better than applying manure over a snowpack. And so regarding the research needs or what gaps there may be in existing research, I feel like we do need a better understanding of nutrient cycling during the non-growing season, and particularly during the microbial activity or the transformations that occur with nutrient cycling based on microbial activity. So when I was reading the literature, I could go to a forest ecosystem, for example, and I could see the entire nutrient budget for that forest ecosystem for every season of the year. And that was a little bit more difficult to do when I was looking for literature that relates specifically to agricultural research. So, determining what transformations occur under the snowpack or in the snowpack or in the soil during winter is a little bit harder when it comes to agricultural watersheds. And so that's one area where we may need more research. And another area that I thought needed a little more research was the antecedent soil moisture conditions. So just because depending on how much water is stored in the soil profile, that could have an implication for how much runoff we're going to have that following spring. And so, is there a correlation or is there a causation, effect? And so we will need to study that more. And then, of course, climate change or the effects of climate change are also important when it comes to winter. So as you already know, climate change effects are not the same throughout every season. So the winter season is actually experiencing more warming than other seasons of the year. And there is this really amazing research that, or this really nice paper that I believe is coming out soon from Dr. Tracy Twine and Dr. LAAS are publishing a paper sometime soon. And so they talk about the effects of climate change specifically in Minnesota. And so that is a really interesting read that I recommend to you once it comes out. And so I am really grateful to be in this program and to have done this. And I really could not be here without the support through this program from Dr. Melissa Wilson, my advisor. So I really appreciate having her in my program and her having her knowledge and expertise throughout this process. It was really nice. And I'm also grateful for my committee members, Dr. Diana Carwan. Dr. Carwan is, as you know, she's a hydrologist and she also knows a lot about snow hydrology. I got to learn a lot from her during a class that I took with her. That was a forest biogeochemistry class where I was allowed to talk about snow. And then Dr. Lindsay Peace, of course, as you already know, she is an expert in nutrient management, particularly phosphorus. So really grateful to have her in my committee as well. And also, there were many people that were key to my success here and to my work that I did here. You know, all of this work is not done just by myself. You know, I could have not done this by myself, of course. This is collaboration, and this is work that is done by many people in our labs. And so I thank them for their contribution. And then, of course, I took a lot of classes and I have a minor as well. So I did take a lot of classes here. And I am very grateful to the professors who are just inspiring. You know, every professor here really cares about my learning, and I really appreciated that. The staff are like family, right? I mean, you know that without Perry Jarko, we would just fall apart, right? And so also the students here are just, you know, great to work with as well and to learn from. And then lastly, I would like to thank my family. I've had a very non-linear path coming here, right? So I have a previous career. I'm a first-generation immigrant, and so it's been quite a path. So I am really grateful for my husband, David Allen. He believed in me and he supported me through my career change. I really was feeling very frustrated with being in the business world, and I wanted to always be in the sciences, and I was able to do this because of my husband, and I really am very grateful for this opportunity. Also, my mother, Victoria, made a lot of sacrifices for me to just come to the United States. And so I'm grateful for her as well. And then my family, my siblings are very supportive of me. We're a very united family. My sister Erica, my sister Griselda, my brother Rigo are just incredibly supportive as well. And so I will take any questions if you have any questions at this time.
Well, everyone, let's give Luis a round of applause. So thank you so much. I just want to point out, Luis, that you have 45 people online listening to your talk today. So
thank you so much. I appreciate everyone being here.
So with that, we do have lots of time for questions. So feel free to either raise your hand, or if you want to put some in the chat box, I can read those off to Luis as well. Or if you feel like unmuting yourself and asking a question, feel free. And so far, Luis, in the chat box, I hope you get a chance to read these. There's lots of congratulations for you.
Thank you.
Also, Tracy Twine mentioned her paper is out and she linked to it. So
it is out. Oh, nice. Oh, that was an incredible read. It was, I think everyone should read it. You know, it's just climate change affecting our state over the next century or the next 100 years, I believe, something like that. It was just really, really nice to read.
Awesome. All right. Any questions so far?
Hi, Melissa. This is Gary Flat-Rising.
Hi, Gary.
Great job, Luis. It was really, really well done.
Thank
You're
you.
very smooth as a speaker too.
Thank
Polished.
you so much.
And I have to say that Luis, I got to meet him when he first came. We were across the hall before COVID, and shared our stories back and forth. I was a non-traditional as well, and you've really done a great job. I like, and I'll send you what I think was really good about it, but just even digging into the literature there and pulling out some things for us to think about. Very mature and methodical. Good job.
Thank you.
I had a couple questions. I think with the lab study, it's always been intriguing because I've worked with Peter Vadas on this kind of, snow in the column or cone experiment. And I just want to confirm that the P application rate was the same for the treatments. Is that correct?
Yes. So we did apply. So we applied exactly 50 grams per each of the columns, and that ended up being about 30 something kilograms per hectare of phosphorus. Okay. Correct. Yes.
So then the question is, like at the bottom, the over snow treatment had less phosphorus that came out the bottom. Where did the phosphorus go? shouldn't it, if it all,
Yeah.
leached out, shouldn't it be the same?
Yeah. So we had and this is just a guess, we didn't study what actually happened there. It was an observational study, as you know. But what my guess is that because there was not as much water contact with that oversnow manure, that phosphorus was, somehow protected within the manure. It may have been protected. And so then it just remained in that manure on top. So when I didn't have any pictures of this, but when you look at the manure under snow and what is left over after all of the snowmelt is completely gone, we did see more manure on the screen, that the mesh from the over snow manure than we did on the under snow manure.
That's a great point. And then what I wanted to ask one more thing, which you didn't really show, is the temporal loss. Can you just comment on that? I think you had 4 or 5 samplings. Can you comment on the temporal loss?
Mm-hmm. Yeah. So over sampling, we did observe that the phosphorus losses were increasing over time as we sampled. So that was the temporal loss pattern. And
was it the same for all the treatments, or I would think maybe?
Yes, actually it was. Yeah, it was very similar for all the treatments. The manure treatments, that is. Yeah. Mm-hmm. It's just a different. It's like almost the same slope, but a different position within the y-axis, because our y-axis being the kilograms per hectare.
Mm-hmm. Thank you.
Thank you. Oh, and I have to say, before COVID happened, Gary was feeding all of the graduate students amazingly delicious desserts. So thank you, Gary.
I wish I could have been doing it the last 2 years too.
Yes.
Great, thanks, Gary. Were there any other questions for Luis? Trying to keep track of, see if there's any hands. I think they would pop up at the beginning of my screen if there were. All right, well, if we don't have any further questions, we will let you all head out. Luis and the rest of the committee members and I will be going to a separate Zoom to do the closed portion of his defense. So good luck, Luis, to the rest of the committee. Let's go ahead and take a break and reconvene at 2 at the other link. Does that work?
Yes, thank you so much. Thank you everyone for being here. I appreciate it.
Let's give a last round of applause to Luis. Thank you. Thanks everyone for coming.